Mm. So this will be the Geotechnics ETG 3173 module. So first of all, we will discuss about soil improvement. So the question we should ask, why we need to improve soil? The answer is the existing ground, shear strength. What is shear strength? I think we did last semester. Friction angle and cohesion is not enough. We call bearing capacity to bear the foundations, excavations, or etc. The soil's strength is not enough. So to increase the shear strength, we have to do soil improvement. The another objective is to reduce the compressibility, means consolidation. So imagine you, without improving the ground, you construct something, but with time, it settles. So one of the, there are like the consolidation settlements, you can see that tower of Pisa tower, that, inclining tower. So that's another example. So another objective is reduction of permeability to minimize flow of groundwater. To prevent inundation, inundation means groundwater filling up, so we have to evacuate, or water damage. So imagine under your house, you have the foundation, but if you don't compact, it means what? You have high amount of porous spaces, void spaces. The voids can be filled with air or water. So in rainy time like this, so there can be huge water flows under the ground, then it will wash away the soil, and sometimes your house can get damaged. So reduction of permeability to minimize groundwater flow. And then another objective is prevention of liquefaction or reduction in lateral spreading of new or existing structures during earthquakes, etc. Okay. So I think so far we discuss only the first one. Why we need to improve the soil or compact the soil simply to get it ready to make our foundation, but there are some other uses as well. So one of the first oldest method is removal and replacement. So let's say when you go to make your house, you found out the soil is not that good. Let's say organic soil, like you find in Muthurajavel. So they are peat, like blackish color. They cannot support the load because they are mainly made of organic material. So not like sand. So then contaminated soil sometimes, leaching ground, etc. So then early days, what they had to do for some cases, nowadays it is also done, totally excavate the soil, dump it somewhere else, and bring some good, it means well compacting soil, and fill by layer and layer, and construct your foundation. Removal and replacement. So that is one of the oldest site improvement or soil improvement method. But this method is usually practical only above the groundwater table. Because if it's below the groundwater table, then we have worries or problems with water, so it becomes a well. So the other mechanism is shallow compaction. Shallow compaction is something that you see every day. Like if you look at a road construction, etc. So if you see rollers, compactors, etc., those are called shallow compaction. Okay. So to conduct this shallow compaction, various factors like type of soil, whether let's say simply sand or clay, compactive effort, how much energy that we have to put in. Like if you remember last semester, you did Proctor compaction test, standard and modified. So standard one is there, but modified one, it has a higher compactive effort, means higher energy. The size of the hammer was big. Okay. Then there's another factor, water content. So you saw when we change the water content, moisture content, how it changes. And organic content, the presence of organic materials and their content. Okay. So after considering those factors, if you're doing shallow compaction, they will look at thickness of the lift. It means height of each layer. So if you remember when you're doing Proctor compaction, so standard Proctor compaction, you fill with 3 layers. So you maintain the lift thickness, height. Okay. And then there's another factor, deciding factor, type of roller. So I'll discuss about the various amount of rollers. And then the number of roller passes. So how many times the roller should go? Like simply like when you're doing Proctor compaction. So if you doing 25 blows, so that's the number of roller passes. So area, what's the area the pressure should be applied, so once you fill the soil up to a certain height, it will compact, means its thickness will lower. So to decide how much soil you fill in, so those are the factors to be decided, or specifications to be decided. So let's look at some of the examples. So this one called smooth drum roller. This is a drum, metal drum. The surface is smooth. So you have seen a lot of road construction where this sort of rollers are used. This provides a smooth finish surface. And the more highlight is effective only up to 30 centimeter lift. 30 centimeter means 30 centimeter means nearly 1 feet. So in the exam, I might ask, compare shallow compaction methods or machinery that used for shallow compaction. So you should be able to tell, okay, there are smooth drum rollers, and let's say another example, sheep foot roller. So what's the difference? Similarities, differences, etc. Okay. So sheep foot roller. The sheep foot roller is used mainly for compacting clayey soil. So you can see the surface is not smooth, so it has sheep foot kind of like things. We call that to provide kneading action. Kneading means if you have a smooth surface like this with clay, clay will get attached, glued, because clay has cohesion. But with this, clay will not attach, so it will knead, it will press, greater compaction pressure. Then there's another type of roller, pneumatic rollers. Pneumatic means tires. So with air pressure and etc., pneumatically it rolls. So this sort of rollers mainly use bituminous laid, like pavement, so road surface finishing or carpeting work, etc. So you will see, if you see some road construction, go and have a look. So you will see this sort of pneumatic rollers as well. Once they lay the bituminous mix, so they will compact with that. Then there's another one, vibratory roller. I think we discussed this during the soil mechanics as well. Vibratory roller. This is effective for granular soil, not effective for clayey soil. Okay. So that sort of things are there. So those are the shallow compaction methods. So shallow, not very deep. The next one is deep compaction method. So deep compaction means, so you saw shallow compaction means the compaction effect, that energy is passed onto very smaller depth. But deep compaction means the energy that we are placing to compact this will be passed on to a considerable depth. So there's a crane, it will lift weight, 5 to 30 ton weight, and then drop. So you see this sort of, we call crater or holes. So you can see when having a hole means what? So that much void has been removed by this force. Now they can fill it again with soil and prepare the site. Okay. So this is a cost-effective method for densifying loose sand and silt. So if you have loose sand or silty soil, let's say like a coastal area or like that, this method is very useful. Then there's another most effective in sand, still that deep compaction or dynamic compaction. So this is effective for about 2 meters. So 2 meters should be enough. 2 meters means nearly 6 feet. 2 meters means more than your height will get compacted. So dynamic compaction, so we did the same thing that we discussing. So there are a lot of details given here. So you can read through, but during the understanding, your understanding should be, so what are the advantages, disadvantages using certain mechanism? Or if you have a clay soil, what will be the most effective way of improving the ground? If you have a sandy soil, silty soil, what would be the effective way? Okay, so this deep compaction, dynamic compaction, effective for sand or cohesionless soil, silt, etc. So these are some of the photographs showing how they have done. So so this is the sort of weight that it's being lifted and dropped. So once it drops, it will make holes, craters. We call craters like this. Okay. So this is actually real good diagram. Let me, if you look at here, so it will show how the energy that being applied is passed on to the ground and how it densifies. So with this, so you can see there's a certain, let me select another column. So first drop is here, second drop is here. So you can see it not densifying this area, but it densifying this area. So if you want to densify the blue colored area, what you should do, first you have to drop it here, second you have to drop it here. So you have to go very close gaps. If your gap is larger like this, so it's not compacting the very top surface but below that. So like that, that's a technique to apply. Okay. Now, the second method is vibrocompaction. So that's dynamic compaction. This is vibrocompaction. Vibrocompaction means what? We are using a vibration. So if you So earlier, with deep compaction, we can compact up to about how much? Let's say with this 4 to 8 meters, or here we said it's effective for about 2 meters, like that, based on the weight. But let's say maximum 10 meters. But if you want to compact more than 10 meters, we have to do vibrocompaction. What is vibrocompaction? You drill a hole, insert this probe, and then we're doing vibration. So you have seen when they're making concrete, the poker machine. So that is also a vibration kind compaction. With the poker machine, when you vibrate, you will see the air bubbles comes up. So it means the voids are removed and the concrete, fine aggregate, coarse aggregate, water, and the cement, that mix is being brought together. Okay. So this vibrocompaction or vibratory probe compaction is the same thing, but that is also effective for cohesionless soils. So if I may ask, what's the difference between vibrocompaction and dynamic compaction? Vibrocompaction can both using the most suitable for cohesionless soil, but vibrocompaction can be effective for very deep compaction, like say more than 10 meters. But dynamic compaction may be effective up to 4, 5, 6 meters. Yeah. So this is the vibrocompaction. So you can see once the probe is inserted and vibrated. So left side, it's not settled. Right side, you can see it's as it is, but when we vibrate, it will come down. It means voids will get removed. So when we doing vibrocompaction, so advantage of vibrocompaction is what? We can go to a large considerable depth. But then there's a disadvantage. What? When we vibrating this, the ground vibrates, yes, and densifies, but the wave can propagate it through the soil layers. And imagine if there's a house nearby, that will also vibrate. That this vibration can get structural damages to the building. So building might collapse. So we have to look at that vibrations before we doing vibrocompaction method. Then the third deep compaction method is vibroflotation. Vibroflotation. So there's a vibration, but there's a flotation as well. So what is a flotation? It means it floats. It means water is used. Okay. So for sandy soils, it's very excellent application. For clays, we cannot apply. You can see mainly. Okay. If you have silty sand or silts, it's also not very good. Only useful for sand. So what we do while applying the vibration, like the previous method, also we will apply some water, so it helps the particles to come together and voids to be released. Same as in the Proctor compaction method, if you remember. Initially, water helps soil particles to go to other place and compact more. Okay. Right. Then there's another method, vibro replacement stone column. So this is actually done to address compaction of clay soils, cohesive soils. So vibro replacement stone column. So stone columns are used. So the idea is we make a hole in the ground and then we add stones or some granular material. The reason is if you have clay soils, we will do the next topic, consolidation. So removal of clay soil water, it's very difficult. Why? They have cohesion, adhesion, like it's like a glue, bonded. So this adding this will enable us to take out the water. Then the other mechanism we discuss dynamic compaction, and then vibro compaction, then vibro flotation, then vibro columns with sand or stone columns. Okay. Now this is another method, preloading or pre-compression. So this is a method that we can use for clay. So what we are doing for clay soils, we load. So we try to fill this with some clay on the top. So that will apply force. So you can see the soil type is saturated clay. With this force, it will force the clay layer to get consolidate and remove water. Right. So this pre-compression, you can see effective for large-scale project sites. So and clayly soil. So one of the main thing is clayly soil. This is used for clayly soil. So further discussing or describing about the pre-compression or preloading. So you can see surcharge field. So additional load that we put in, if we have put a higher load, so we can get higher settlement, higher compaction. So this mechanism is most effective for clay soil. So there are advantages and disadvantages. So what are the advantages? So this is mainly we are filling another layer of soil or something, anything else to input, put a load onto the ground. So with that load, it will consolidate. So this requires conventional earth moving equipment like excavators, dump trucks. Sometimes nowadays they put water tanks, etc. To pre-compression. Any contractor can perform this, so you don't need much technical standards for this. And long track record of success means for a long time this has shown this method is successful. Disadvantage: surcharge field must extend horizontally. So if your land is here, if you want to compact it, but you have to ask or get the neighbor's land as well. Why? You can see you need a bit more higher space to compact this area. Then moving of large quantities of soil required. Imagine, especially if you happen to have this pre-compression during rainy time, going to be very difficult. Dry time, it's okay. So then another thing is disadvantage is the surcharge, this added load, added field should remain there for months or years. So which we have to delay the construction process. So imagine if your project get total construction period of 3 years, and if you have to do pre-compression and leave it for 1 year, it means you lost like 1/3 of the time that allocated for the project for this pre-compression. So The reason is for if the project is time sensitive, if you have to finish quickly, then we can't use this method. Then there's another deep compaction method is by vertical drains. So drain sort of thing. So drains, what they do, so we drill a hole and then we put a rubber lining so we can pump the water out, which will enable soil to consolidate with the removal of water, like this, vertical drains. Okay. So some cases we can have like a surcharge load and then drain as well, both or even only the drain. So the other variation of vertical drain is prefabricated vertical drain. Prefabricated means the polythene or that kind of rubber roll is there in the machine. So machine drills the hole and insert the drain, vertical drain, and take it out. Then we can pump. I'll show you some photos. I think in this one you can see some rubber type of things comes up. Those are the vertical drains. So I think I had some. No. So I had some, I thought I had some photos, I'll add them. So you will see like there's kind of like, let me highlight it. Tubes comes up. So it means there's a hole and the vertical drain has been installed. Okay. So you can see the gap, 3-meter gaps, etc. So based on the depth of the field. So in this case, there's another type of vertical drain we call big drains. Big means, again, big means remove a collection of water and then we can remove it pumping. Okay. So there you can see some of the installation of big drains on the ground. So very close spaces, etc. So big drains also installed by heavy machinery. So like you will see these kind of rigs where they install big drains. So these are some of the types or the brand names they have in United States. So we discuss all the so far all the mechanisms, methods of improving the soil using machine energy. Machinery. Then now we're going to discuss soil improvement using admixtures. It means like grouts, cement mix, etc. Rather than loading, what if we use chemicals or admixtures, put it into the soil or pumping into the soil and improve the ground. So mixing admixtures into soil has been shown to be greatly beneficial. It means mostly useful to dry up wet soil. One example is, let's say, nowadays we received a huge amount of rains, most of the western province, southern province, suburban province, etc. So if you want to start a construction project now, the ground is very wet. Having wet ground makes soil excavation, soil transportation, those things very difficult. So some cases, if you want to dry up the wet soil, you can use chemicals, what we call admixture. Okay. then improving strength. Volume stability. Volume stability means the consolidation will be less if you remove the water. So if you remove voids as much as possible, consolidation will be very less. Then reducing erodibility. Erodibility means erosion through the flow of water. Then improving durability to dynamic loads, for example, earthquake loads. Then moisture control. So those, I have asked this in one exam. To improve soils, what are the uses of mixing admixtures? So why we add chemical or any other mixture to soil? So these are the ways that it will improve the soil. So even when you selecting the admixture, it means type of a chemical. So one of the common admixtures are cement, lime, etc. So variables that you have to look at the type of soil, purpose of use, like if it's a road construction, or it is a residential house, or is it a common public house, public building like a school. So those are purpose of use. And then engineering properties design means for foundation design, what's the requirement of shear strength or bearing capacity. Then availability of material. So whether if you like to get some chemical, but does it available around you for a reasonable price, cost? And then environmental concerns. So you can add anything, but after adding it, whether it releases chemicals to the groundwater, then if so, then you cannot drink that water. There you have to look at carefully the environmental concerns as well. Then one of the first mechanism of admixture mix is cement and lime. What is cement? The cement that you can buy from stores, we call OPCO, ordinary Portland cement. Lime, what is lime? Crushed calcium carbonate. So early days, I'm not sure, you can ask your parents. So early days we had some factories, so they collect the shells, calcium carbonate from the beach, nearby beach areas, and then they burn and crush and make lime. Okay, so in this cement and lime stabilization, so for soil improvement, one admixture or mixture you can use is cement and lime. So this outlines the process, what happens when we put cement and lime. Another thing is like the grouting. So grouting means cementitious grout can be chemical grout. So cementitious grout means cement is grouting means pressurized onto the ground. So like this. You can see, so you drill and then you fill this with grouting. So this doesn't need to be essentially cement. So sometimes these holes can be filled with cement and other times can be filled with chemical. One example is if this is under the water table. So if I draw the water table, let's say this is the water table. If you have a cavity or void space at this depth, can I fill this with cement? We can't. Why? It will wash away with water because groundwater table is here means water is here. So cement will not get solidify, it will wash away. So we have used some chemicals, water resistant chemicals. So admixture, so you can read through about cement and lime stabilization. So it provides much more details. So I'll briefly discuss about the grouting method. So there are intrusion grouting. Intrusion means filling joints or fractures under the ground. Because filling these fractures will fill up these faults and reduce the hydraulic conduct. If there's a water, it will reduce the flow of that water. So this mechanism used to prepare foundation and abutments for dams, especially because dams huge amount of load is being applied, and also having a void like this, if the dam water gets in, so it can create a channel so that the dam water will drain away. Then there's another grouting called permeation grouting. So permeation grouting mainly like with chemicals. So you inject, then sometimes it increases its volume and becomes a solid mass. So there are other grouting mechanisms like compaction grouting. Compaction grouting means what? While we uh, experience some building collapse or etc., you can drill and fill with grouts. So, like Pisa Tower in Italy, so they are doing compaction grouting to reduce the leaning of that tower. Leaning means aligning, or there's an angle. Then Japan, they developed another grouting mechanism called jet grouting. So jet grouting, so they inject grout, not just pumping, but at very high pressure. So that is useful or valuable tool mechanism for soft soil. Soft soil means not very hard or like higher void spaces. Okay. Underpinning. Underpinning means another sort of deep excavation support system. And also grouting, since it's filling void spaces, we can control the groundwater. So controlling the groundwater means not just blocking it, but we blocks and divert that water to somewhere else. Okay? So then, so this is still, we are talking about using admixtures, soils, cement, lime, asphalt, etc. So this using admixtures is mostly uh, effective for clays kind of thing. So because lime usually it absorbs water. So when we put it into the clay, it absorbs water and fast make the consolidation process very fast. Then we are reaching the final pass, reinforcement. Not only the mechanical or chemical methods, but there are some geosynthetics we can use to increase the soil's behavior in tension. So compression is just compaction, but what if it's subjected to tension? So that's why we use geotextiles. So there are several, we call geosynthetics. Geotextile is kind of like a cloth. Geogrids, it's kind of like a small grid. Geomembranes, or membrane is something that passes water. And geocomposite, so that's a mix of uh, existing geosynthetics. So I'll show you here. You can see a wall is constructed. So the reinforcement, you can see some geosynthetics have been laid, and then filling with soil with the doser. So you can see layer by layer. So they fill and then they add this geosynthetic. So to improve the load supporting tension. So another this is very similar example what you do when you concreting a beam or column. So why you add reinforced steel? Because to improve the strength in tension. As concrete mix, or once they get hardened, it's not very good for supporting tension. It's good for supporting compression, but not for tension. For tension, we have to use reinforcement. So etc. And here in with soil, we can use geosynthetics. Then another concept is soil nailing. This is widely used in Sri Lanka. Even when you're traveling on highway, or if you go to Nuwara, that area, you will see a lot of sites they have done soil nailing. It means if there's a collapse happening, so we try to nail that soil. Nail means connect that soil, push that soil back into the place. So I will give you a bit more photographs later. So how the soil nailing is done. So drill a hole and insert it with some adding some grout, and it gets solidifies, and then from the surface we connect all the nails. So that way it is much more strong in tension. Okay. So that's the end of it.